Hello, this is Zach, and today I'm going to be showing you how to install and set up Total AI. So let's get going. Okay, so to start, go into Unity Hub and create a new project. Type in whatever name you'd like. Then click Create. Okay, now once your new project is open, we now need to get the Total AI script files in. So go to the Total AI GitHub repo. You can see the address above, and it will also be in the description. Currently, there are 4 repos in Total AI. So there's a 3D demo, 2D demo, Total AI just scripts, and the website's also open sourced. So go into Total AI core if you just want to start with that. Okay, so go to code, and an easy way to do it is just download the zip file, open up the zip, extract it, and then once the extracting is done, you should be able to go into Total AI Master, and you don't need any of the Git stuff, so just drag the Total AI file. What's nice about Unity is you can just take it and drag it right into your assets directory. That will automatically bring in, copy and bring in all the items in Total AI. Initially, you should see there should be some errors. So the Total AI comes with 2D and 3D. So for this one, we're doing 3D. So depending on what you're doing, delete the one you're not using. So it's usually 2D. And then our last error has to do with the fact that we need Unity's nav mesh system, where you can get the zip, extract it, and then just drag. All you want is the nav mesh components directory. So drag that into assets. Okay, so that's it for errors. So now we're going to want to do the setup. Total AI comes with a nice setup window, which will automate a lot of the kind of boilerplate setup stuff for you. You can see here there's basically 5 different options. So the first one is managers, layers, folders, and then the last one's actually will create a whole bunch of core scriptable objects that most projects will want to use. It also generates a settings file, which in the documentation you kind of look at all those different options. Another thing to remember is when you do that, make sure you check 2D if you're doing a 2D project. So you can see it generated these 3 managers, Total AI Manager, which everyone needs, Time Manager, and then the GOP Planner Manager, which you only need if you're using GOP Decider and GOP Planner types. All right, so now we're going to go ahead, and so that's it for setup. Now we're going to go ahead and show you how to just get a basic agent and world object type going. With the agent is going to basically go to the food and eat it. So here we're setting up the ground. This is just basic nav mesh stuff, so that the nav mesh surface is what came from the nav mesh components. And the nice thing about Total AI is it has a automatic nav mesh surface update. So if you add world objects or something changes, it will know to automatically refresh the nav mesh surface. All right, here we're just going to create some colors, just so you can see everything a little bit better. Do this real fast. All right, so now what we're going to do is we're going to create an agent and just a food. It's just going to be a square and a circle. So we'll name the agent QB. QB will be trying to eat food. That is all we're going to do in this video, just to get you started. All right, so let's have the cube. You see, create an empty and then nested the cube. That's always advisable. It just makes everything much nicer when you kind of have all the meshes kind of nested under an empty game object parent. Alright, so let's just basic setup and get everything aligned on the surface. And that's another reason why you want empty, because you want the empty to be right on the surface. Otherwise it can kind of mess up some calculations, distances and stuff that don't ignore the y-axis. What we're going to want to do first is we want to set its layers. Go and set them all to agent, and now What's nice about world objects is we just add a world object component, and there's this quick create, which uses the settings, the directories from the settings. That's why you want to set those. And then that just created the food world object type and also made it a prefab in the prefab directory. And here we actually want the collider to be on the parent. We basically want the collider to be where the world object component is. So we're going to move it over here. And then we will update, it's a prefab now, so we'll update all the prefabs. Okay, so that's it for food. Pretty simple. And now for QB, we need to add an agent component. There is no quick create for agent. Generally, you'll kind of have to go through this whole process for the first agent type, and then I recommend just duplicating the initial agent type you do, and then change anything on it. Because you can see you got to set a bunch of these. These are all the core types. So this was really nice about Total AI is these types really kind of define how the agent will behave, from moving, animation, decider, detection radius, basically sensors. Again, look at the documentation to go through exactly what all these are. And then these detection radius and movement speed were automatically created by the core script setup. So we want to make sure QB has those two. All right, so now we are creating our first drive. So drive will be hunger, and every drive has a utility curve. So the drive level goes from 0 to 100, but then the utility curve goes from 0 to 1. And so that basically gives you much more power over what the 0 to 100 level means for the drive. Again, see the documentation if you want more information on that. But that comes from Utility AI. So we're going to set the default level to 100, which is the max. So when the game starts, QB will be as hungry as he or she can get. Now we're going to create 2 action types. So we need a go-to action type, which is a special type of action type, and an eat. So QB will go to the food and then eat the food. Every action type has a behavior type, and the behavior type is what the code that is actually run during the mapping. As you'll see, action types have mapping types, and a mapping has a mapping type. So check this. So this is the go-to behavior type, which is good. You can see the movement speed is attached there. So that will determine how fast the agent moves during the behavior type. Now we're going to add go-to and eat to the cube agent type. And we added the drive. All right, so now we're on the agent script. We want to add the agent type, so it'll tell that QB is a cube. There's some other stuff you can set, but we can ignore that. So now an agent is also going to need a NavMesh agent, which ties into Unity system, which is Unity's system for moving NavMesh agents. And we also need a non-root motion movement. That is a Total AI script, because this will not have animations at all. That basically is responsible for moving the agent smoothly. And again, that is called in the movement type. So if you customize movement type, you can change that or write your own movement script. We also need a collider so that the agent... All right, now let's start and see if there's any errors. So it looks good, no errors. Here we'll add a simple camera controller. This is actually from Unity's default project, I think URP. And this is just nice because it just lets you move your camera around. It will be picked up. Here is the other window that Total AI comes up, the tie agent view. And this gives you a real nice overview of all the agents and exactly what they have. And also while the game is playing, you can see the plans, which is like a plan tree, and history, which was from the history type, and that the default history type records everything. So now we need to make a mapping type. So the mapping type is what actually an agent will actually decide to run. So there's a bunch of stuff on mapping type. The major things there has input conditions that must be all true for the agent to be able to run the mapping type, and then output changes, which is what actually occurs during it. Utility modifiers kind of is like a utility AI type modifier, lets you change the utility for doing that mapping type. And then target factors and inventory target factors have to do with how the agent decides what targets, if there are targets needed in the mapping type. So for example, in this one, the target would be the food. So we are going to need a target factor. All right, and we are going to need a destroy entity output change type. So an output change has an output change type, so that is needed so we can destroy the food once we've eaten it. So the input condition here is that you only need to be near a food entity type, and there's 3 different match types. This is the simplest one where it only can match on an exact entity type. Output changes, we'd basically destroy the food, and this is 2 entity target. So, and then we also want to decrease the drive level. So that's what actually motivates the agent to do something. So we'll just say -5. So if the agent is near it, then it can do that. And to get near it, it uses that go-to action type. And as you'll see, the go-to mappings are automatically generated if TotalAI determines that a go-to mapping is required. So now we need to make a target factor. A target factor has, the one we're using needs to have a min-max curve. A min-max curve is, I know what it says, it's basically you got a min and a max and a curve between it. So you can pick different types of curves. Like this example is we're going to want a line, which means we're going to get a uniform value between 0 and 1. So basically the input is the X and the Y is the output. It's going to give you a uniform random. So it's going to pick a random value on the X, and of course since it's linear, whatever it picks on the X is what it gets in the Y. So this target factor is completely random. So as we'll see later, if you do have a bunch of foods, it will just randomly pick one to target. Now there's other target factor types that make more sense. Probably the one that's used the most is the closest. So in that case, the agent will just go to whatever entity target matches that is the closest. So you can see here, there's a few already. And of course, like all of TotalAI, it's designed to be easy to make your own types. All right, we'll move the food out a little bit. And then we will realign the camera to start. So we have to move it around. And then let's see if it works. And it did not work. So it looks like if we look in the debug, we forgot to add interaction spot type. So each entity basically has to define how it is interacted with. So nearest interaction distance is the simplest. It's just going to find a spot near the entity closest to the agent. So the agent will just takes like a circle around the entity and goes there. And you can also set different interaction spot types per action type. So each action type can have its own interaction spot type. Okay, so that works. So it goes to food and QB eats it. So pretty exciting. And here you can see the plans. So because we're not running, it's not going to show you. Let's see if we can get it to show you while it's running. All right, so here now you can see, so it automatically added the go-to mapping. So the yellow means it's running it. So it's running the go-to food mapping. And then if I play it, it will then go. There you go. That was pretty quick. But it finished go-to, went to eat, and it ate the food. And you can see the hunger went down. All right, so let's stop that. Now, let's, like I said before, let's make a whole bunch of foods. And all right, so now there's a bunch of foods. So you can see it's not going to the closest one. Now it's going to randomly pick one to go to. we go show the plan, so now you can see its hunger has gone down as it's eating, but it's going right back up because it's set to go up pretty quickly. If we go to plans, you can now see it going to the food and some of the history. So you can see this, all the output changes it's run. And like you look in the documentation, you can read more about decider and behavior. These are plans, so you can see it just keeps eating, and it ate everything. All right, so thank you for watching this, and please go to totalai.org for more information.